Alright, today we're looking at Math 2, Unit 5, Lesson 4. This is homework help number 6, 7, 9, 13, and 24, dealing with properties of rhombuses, rectangles, and squares. It is important for you guys to start to memorize the different features of a rhombus, a rectangle, a square, knowing that a rhombus and a square have equal sides. The difference between the two being primarily that a square has to have 90-degree angles, just as a rectangle has to have 90-degree angles. A rectangle just has to have two parallel sides, but they don't have to be equal all the way around like a rhombus and a square do. So make sure you know the difference between all those things there. Let's look at the more the work you have to do here on this lesson. We're looking at the measurements of different angles within a rhombus. They do tell you here that a diagonal of a rhombus forms an isosceles triangle with congruent base angles. Remember back in the day, when you make an isosceles triangle, what that means is that the sides are the same, and when you have an isosceles triangle, the base angles are identical on that base. This would be a different length there. Okay, and as always, the sum of your interior angles is going to add up to 180 degrees in a triangle. I share that because when we get over here to look at our first example, number 6, when I see what's given, I can see that they gave me the value of maybe the peak of the triangle at 73 degrees. Okay, now when I look over here, I recognize that this is the base. Here's the base, and here's the base here. These two angles are going to equal one another, just like my sample triangle did up here. So what that means for me is this. The sum of all these angles will be 180 degrees, right? Because that's what a triangle looks like. If I take out the top part here, the 73, and I put a 7 there and a 10 there, I end up with 107 degrees left in this triangle. Does that make sense? So I have 180 degrees total in here, and I've already used 73 up there. So what remains for these two angles is 107 degrees. Because it's isosceles, these are going to equal each other, which means that I take 107 degrees, and I'm going to divide that by 2. And when I do that, I get a very strange answer for this problem, which is 53.5 degrees. That seems very odd to me. I don't have an answer key to verify that's correct or not, but 107 divided by 2 is what I end up with. So just a little different there. So I could say that the measurement of angle 2 and the measurement of angle 4 are 53.5 degrees. Because this is a rhombus and it divides this evenly here, I also know that because of alternate interior angles, number 4 equals 1 and 2 equals 3. So I can just add on here that also angle 1 and angle 3 also equal 53.5. So a little different to get a decimal as an answer, but it does happen from time to time, so don't always expect lovely round numbers for you. I'm going to do the same thing with number 7. When I look over here, I can see that they've already given me 106 degrees on this point, and what remains then are my base angles of the isosceles triangle. So using the same strategy, if I start with 180 and I subtract 106, I'm left with 74 degrees for angle 3 and the one that's not there. So I'm going to go ahead and divide that by 2 to see what the measurement of angle 3 is going to be. And 74 divided by 2 is 37 degrees. So my measurement for angle 3 is 37 degrees. And like we've already said before, alternate interior angles, I have a 3 here, I have a 2 there, so I can safely assume that the measure of angle 2 is going to also be 37 degrees. For angle 1, that's pretty much a given because we're going to go straight across from here to here, and so angle 1 is going to equal simply 106 degrees there. Let's take a look now at number 9. Number 9 is a lovely one here. It does remind you that the diagonals of a rhombus are perpendicular. What that means is that where they cross in the middle, we end up with 90-degree angles in this middle section when it's a rhombus. If it's not a rhombus, It doesn't have to always be 90 degrees, so keep that in mind. A rhombus means that all the sides are equal. So because all these sides are equal, when we cut it across the middle, we get a 90-degree angle there. So already what's given, the measurement of angle 1 is going to be equal to 90 degrees. That's handy. Nice to know that. So because that's 90, let's go ahead and draw this again real quick for you. I have a triangle that looks like this. Here's my 90 here. It's probably not a very good triangle, so I'm trying to make this one bigger right there for you. Right, so, oh, that's horrible. That's okay, let's pretend. So that's 90, this is 25, and because I know that this has to add up to 180, I could look and say 90 plus 25 is 115, and ask myself, well, what's left over here in this little space? Well, I do 180 minus 115, and I subtract, and I end up with 65 degrees down in this little corner. So I could say that in this space, I have 65 degrees. Alright? There's lots of ways of approaching these kind of problems. I could go to that angle first. If you wanted to go somewhere different, that's okay. For example, you might have noticed, hey, we have that alternate interior angle again. 25 degrees here, so angle 4, measurement angle 4, is also 25 degrees. You could look at that. Not a problem at all. Okay? So, if that's 25 degrees, and a rhombus bisects this perfectly, I also have 25 degrees right there. So with this larger triangle, I'll get a green one out here. I have this guy here, here, and here. 25, 25, that's 50 degrees on this isosceles triangle. There's my equal sides isosceles. So if I have 180 degrees minus 25 plus 25 is 50 for 130, that tells me what's left right here is 130 degrees. They're not asking me for that. They're asking for just a little bit. Well, what's half of 130? What do you know? It's 65 degrees. So that also then tells me that angle 2, measurement angle 2, as well as the alternate interior angle, the measurement of angle 3, are both equal to 65 degrees. So there's a couple different ways to get there. It's up to you which way you prefer and what do your eyes kind of see first. Recognize what's given. Recognize that in the angle 1 in the middle, 90 degrees, it's a given. 25 here, alternate interior angle, given. 3 and 2, okay, we're going across, so now I have to do a little bit of work remembering what I know about triangles to prove that to be true. Let's look at the back side here. We're going to look at numbers 13 and 24 to wrap up this session here. So on number 13 and 24, might be helpful for you to visually see what's happening. It says we have QRST as a rectangle. You can notice they don't give you a picture. So I'm going to go ahead and draw one real quick just so I know what I'm working with. QRST. It's really not a difficult problem, but it's nice to see what I'm working with. And I write it in order of what they give me. I apologize there. QRST. I'm going to write it out as Q and go around the clock. QRST. And we're looking at the x value of each diagonal. So they tell us that QS, which is here to here, is equal to 5x plus 12. With a rectangle, because it's 90 degrees, we know that the diagonals are going to be equal to each other. So then they tell you that RT is 6x minus 2. And what we know, like we just said, is that those two lines are going to be equal to each other because it is a rectangle. Now all I need to do is solve for x. So let's subtract 5x from both sides. So now we have 12 equals x minus 2. Let's add 2 to both sides, and we find out that x equals 14. Okay? You do the same type of thing for the other ones, setting them equal to each other on the diagonal lines to determine what the value of x is going to be. The next few questions are really you explaining why these are what they are and give the precise names for them based upon the values there. Let's look at one final one, number 24 down here. Because it's a rhombus, once again, I know that these are all going to equal each other. In fact, all of these lines are going to be equal to each other. So I could say that x plus 14 equals 2y plus 4, but that's going to give me two different variables I'm working with, x and y. I would rather not. I'd rather say that x plus 14 equals 5x minus 2 and solve for x, and then solve for y independently. So that's how I'm going to set it up. I'm going to set up and say x plus 14 equals 5x minus 2. Let's subtract x from both sides. So that 14 equals 4x minus 2. Let's add 2 and add 2, and 16 equals 4x. And so then when I divide both sides by 4, I end up with x equals 4. 16 divided by 4 is 4. Now I can go ahead and solve for y while I'm here. And we have 3y minus 3 equals 2y plus 4. Let's subtract 2y, Let's cancel out, and we have y minus 3 equals 4. We add 3 to both sides, and we finally come to the conclusion that y equals 7. And there we go. Our two values are x and y. It does say to then, don't forget this last step, then find the side lengths. So now I need to go back and I need to plug that value into one of my equations. It doesn't matter which one you do, because it's a rhombus, they're all going to equal the same thing. So just for ease, I'm going to go ahead and take this x plus 4 and stick it in that equation. So I end up with what? Oh, 4 plus 14 equals 18. So the length of every side on this rhombus should be 18. I could verify. I could put a y equals 7 and check over here. 2 times 7 is, 14 plus 4 is 18. I'm in good business right there. Good shape, easy to do. All right, that's it. Thank you.